Hi, this is Chris Gobler, and I'm providing an update with regards to the Sag Harbor Water Quality Project provided by my lab at Stony Brook University. And so the presentation is going to involve a series of data sets, some of which you've seen before, others of which may be new. And so I'm going to start out by talking about some experiments that we performed in order to understand the types of nutrients that might be promoting water quality impairment in Sag Harbor and Sag Harbor Cove. That's shown here. This data set shows the effects of different types of nutrients on the growth of algae, and this is water from Sag Harbor. And so for these experiments, we collected water, brought it back to the laboratory in Southampton, filled bottles with that water in triplicate, and then amended the water with nothing. That would be our control. Amended it with nitrogen, with phosphorus, or both elements. And we performed experiments in June, July, August, and September. And while our June results were inconclusive, it was very clear in July, August, and September that excessive nitrogen loading led to a significant increase in the amount of algal biomass compared to the control, and that phosphorus had no effect, and that nitrogen and phosphorus had about the same effect as the nitrogen alone, pretty much reinforcing the fact that nitrogen was driving algal blooms and phytoplankton productivity in Sag Harbor. We performed the same experiments in Sag Harbor Cove and using water from Sag Harbor Cove, and essentially got the same result. I'll emphasize these experiments were performed in just 24 hours, and just that short period of time, I will emphasize that the increase in phytoplankton biomass compared to the control was very large. Double, sometimes triple, approaching almost 4 times higher in just 24 hours, showing this is a highly nitrogen-sensitive ecosystem. This next data set is about a sediment survey that we performed across Sag Harbor and Sag Harbor Cove. This is part of our nutrient loading study. Now that we know that nitrogen is the element that's promoting algal growth in these regions, now we know what the nitrogen sources are. And unlike, I think, almost every study that's been done to date with regards to Long Island water bodies, this study will include a comprehensive analysis of the role of sediments in nitrogen loading. So this slide shows the qualitative sense of the sediment in 18 stations we sampled across this region. What it generally shows is we've got sandier sediments to the north within Sag Harbor. As you get back into the cove, the sediments transition to being muddier. We also measured the amount of organic matter content as a percentage of the total weight across the different locations. Organic matter content generally trends with nutrient loading, nitrogen loading, and what we found is that the back of Sag Harbor Cove had highly, not only muds, but muds that were highly enriched in organic matter, a few pockets of high organic matter sediments in other places as well. And then finally, we also measured the depth of muds in different locations, and again, that back part of the cove had very deep muds, almost a meter thick, similar amounts in this region here, also out within the harbor. And so the next step of this study is going to be to perform what we call benthic nutrient flux experiments. So now that we know where the muds are, we know those are the sediments that contribute nitrogen via benthic fluxes. We'll be collecting cores of sediment from these regions. We'll be incubating those cores under ambient temperature and light conditions in order to precisely quantify the amount of nitrogen, mainly in the form of ammonium, coming out of sediments going into the water column. This will be then integrated into our nitrogen loading budget. And speaking of that, I'm going to give you the state of the current nitrogen loading budget. It's largely done. although we do need to add some small components like the sediments and some other things. But I'll show you what we have to date. For this study, we collaborated with Suffolk County and CDM Smith as part of the county-wide subwatershed study, so we wanted to make sure our watersheds were consistent with those that have already been drafted. So this shows you both the watershed delineation for Sag Harbor and Sag Harbor Cove, as well as groundwater travel times. Red regions are travel times of just less than 2 years for groundwater, orange 2 to 10, yellow 10 to 25, and green being 50-year travel time. In addition to having the groundwater travel times, we then disaggregated these watersheds to have one specifically that was for Sag Harbor, another specifically for Sag Harbor Cove. What's not shown here is we also added in the watersheds for Long Pond and the regions attached to Long Pond, because these watersheds also contribute towards Sag Harbor Cove. I'm also sending a PDF, so you can probably then see the details of this here. But these are some of the constants that went into our nitrogen loading model. These constants were generated as a consensus as part of a committee that I was part of through the Suffolk County Subwatershed Study. This committee consisted of individuals from Stony Brook, also from Cornell University, from the United States Geological Survey, the United States EPA, from the New York State Department of Environmental Conservation, from Suffolk County, and also from the consulting firm CDM Smith. So all these values we're using were generated as part of a consensus with those groups, and then in addition, the model also consisted of a highly detailed GIS study where we looked at essentially every single parcel that was in both Sag Harbor Village and any area that contributed was in the contributing area for either Sag Harbor or Sag Harbor Cove. And we did a lot of detailed analyses, doing things like obtaining LiDAR data to essentially quantify the precise amount of lawn in every single parcel within this region. Also looking at parks, any agriculture in the region, and from all of these areas, including the atmosphere, determining the nitrogen loading rates. So here's a preview of what the results look like. These results will change because we're going to be adding in sediments as well as likely data from birds. I mentioned that to you in an email, and probably some pet data as well. But without that information, here's what the data looks like. And what it shows is that when you look at nitrogen loading from land to sea for the harbor, the large majority of that nitrogen is coming from cesspools and septic tanks, small amount from the sewage treatment plant, and then you can see lawns and parks become important thereafter. Also the atmosphere. And I'll note for the sewage treatment plant, this is measuring the precise loading as quantified via both the volumetric load and the amount of nitrogen in the effluent. Same exact data for Sag Harbor Cove, comes up with a similar result. Of course, the sewage treatment plant does not discharge into these waters, so its contribution is 0. There's fewer lawns and parks in that watershed, and you can see then therefore the majority of nitrogen loading is coming from cesspools and septic tanks. And while this number seems high, I'll tell you that it's fully consistent with what's been found throughout Suffolk County. We also made the effort to delineate the region that's only within the village's watershed. So these are the regions that Sag Harbor Village can control. And so for Sag Harbor Village, you can see that the amount of lawns and parks nitrogen loading becomes lower, and the importance of the sewage treatment plant increases, but so does the septic tanks and cesspools. And then we look at for Sag Harbor Cove, the number for cesspools and septic tanks gets even larger. And then if we look at both the two subwatersheds, both for Sag Harbor itself and for the Cove, what we see is that within Sag Harbor itself, most of the nitrogen loading is coming from the village, whereas in the cove, the village is only about a third of the nitrogen load, and the rest of it's coming from outside of the village. Moving on to water quality, that's what this data here shows, and what you're looking at here is the idea that, well, you're looking at the different stations. There's no ideas here, just the stations. Station 1 being Havens Beach, 2A are the outfall regions, and let me just say that this map is totally not the scale. We will be providing a scaled map for the final report. And recall, Site 2 has changed in location 3 times. We had the original site, which was by the buoy. We were then asked to move it to the bulkhead, and then asked to move it under the bulkhead. And we did all of that. Site 5 was here in North Haven as an out site for 2018. For 2019, we got water from the harbor master from within the harbor as requested. Site 3 was Ship Ashore. Site 4 was Sag Harbor Cove. And then Site 6 and 6A were within Otter Pond, with I believe 6 being at the eastern extreme of the pond and 6A being in the middle. Okay, so getting into some of the water quality data. This is continuous monitoring of temperature from multiple sites across Sag Harbor, and what it shows essentially is that the water got pretty hot in July and then cooled down going into August. These temperatures were rather extreme, approaching 30 degrees centigrade. That's quite high, and there was some of you may be aware that there was a large base scallop die-off at some point over the summer, potentially associated with these high temperatures. These are levels of dissolved oxygen continuously monitored at multiple sites across the region, and essentially what it shows is that for 2 locations the oxygen levels got below the DEC standard that would be ideal, and for one of the locations, specifically in Sag Harbor Cove, we had near anoxia at least once, and what we call hypoxic or low oxygen conditions frequently through the summer. And this is consistent with the data we saw last year as well. This is salinity, specifically at the buoy. Levels steadily increasing through the season. Recall, I'll first note this increase here is probably just part of the installation of the buoy coming to equilibrium. But in general, you can see levels lower in the spring, a dip around transitioning towards 4th of July, levels low again, and then increasing into late summer. This pattern is fairly consistent with what you see in most locations during the summer, specifically that as you go through the summer months, there's less or low rainfall, high temperatures leading to evaporation, and then a slight increase in salinity. I will note, however, while this looks like a real trend, this is a very small change, 27 to 29. It's almost meaningless. These are continuous chlorophyll data. NOAA would tell you levels should never go above 20 micrograms per liter. You can see there were 2 different occasions when that happened. We call these algal blooms. Going above 20, high levels of chlorophyll can lead to eventually low oxygen and also to shading. These are the pH levels across, specifically at the buoy monitoring station. Ocean pH is generally around 8 or 8.1. We do expect slightly lower levels in estuaries. You can see here levels generally vary between 7.9 and as low as almost 7.7. We would not want to see levels below 7.7 because we know those can be detrimental to marine life. You may be aware of the phenomenon of ocean acidification. That's the phenomenon of increasing levels of CO2 entering our world's oceans and coastal waters and driving down the pH. And so what we would expect is that as we move through the century, as CO2 levels in the atmosphere continue to increase, they will enter our waters, and these levels would expect it to become even lower in coming decades. And so we're right at the cusp of that acidification threshold. Now, since we know the ocean is at 8, what we want to do then is take water quality improvement measures that will bring up those levels of pH, because a lot of these levels here are associated with high nitrogen and algal blooms. And I can explain that in further detail in the future. These are weekly measurements of, or biweekly measurements of temperature. And what you can see is that the generally follow the same pattern as we saw for the continuous monitoring buoy and the other continuous devices. Again, that those very high temperatures that occurred through the late summer. Looks like we skipped here to dissolved oxygen. These are individual measurements, and essentially what these show is that when you take a handheld measurement, they're generally quite high. So we had a few levels that were below the ideal, nothing below the minimum, and this really shows the value of that continuous monitoring. Because for decades, Suffolk County and other organizations, including myself, would measure oxygen and we'd say, oh, well, levels look pretty good, I guess nothing to see here. But that's because what we've discovered is that when you do continuous monitoring, the levels of oxygen get low at night. And so that's what we're missing when we just take an individual sample, and that demonstrates the importance and utility of the continuous monitoring devices. These are salinity levels. Not too much to see here. I'll note that the salinities within Otter Pond, wherever we measured, were nearly identical, but slightly lower, than the other locations. And we did have this occasion here in July, with depressed salinity at Havens Beach, suggesting some kind of freshwater discharge likely associated with the sump that was there, or that is there. Secondest depths are a reading of light penetration through the water column, and so these light levels were fairly low for many locations. In general, NOAA would tell you for maximizing seagrass growth, you'd want 2 meters of water visibility, and definitely never lower than 1 meter. And you can see we're below that 2 meter guideline and hovering around 1 meter. So the water more turbid than we'd like to see for promoting eelgrass growth. Here are the extracted chlorophyll measurements. So this is individual measurements obtained on individual dates. Again, we missed some of the blooms that we saw with the buoy, but even without the chronic monitoring, we did see several locations, such as Sag Harbor Cove and within Otter Pond, of high levels of chlorophyll, also in Sag Harbor proper as well. These are measures of fecal coliform. The DEC would tell you levels should always be above 49 for a region to be permitted for shellfishing. We did see several samples from earlier in the year that were well above that in the vicinity of within Sag Harbor, near the buoy, near the sewage treatment plant outfall. And we had a few other regions that were high as well, one from further out, outside of the breakwater region, multiple samples from within Otter Pond, whether it was to the east or in the center of the pond. The values actually were identical. And then also some high levels on occasion at Havens Beach as well. We also measured Enterococcus. The New York State Department of Health uses Enterococcus as the primary standard for bathing beaches. They want to see below 104 colony-forming units per 100 milliliters. And I put a line in for that standard. Now, thankfully, most samples are below that, but you see there are several from multiple locations that go above that. Otter Pond being the highest. Slight difference in some of the samples for Otter Pond, but still, either way, above the standard. Several from Havens Beach above the standard. That is disconcerting. Because I do know there are people that swim there. I also know that's near the outfall sump. At least one sample from Sag Harbor Cove as well. And then wrapping up the harmful algal blooms. This data is not different from what I presented earlier in the year. We had a small Alexandrian bloom for some locations, and that bloom was over by the time we reached May. In May, we had the ramping up of a Dinophysis bloom. That bloom seemingly was ending in June. We still have to catch up on some of the cell counts from there, and we will be doing that in the coming months. So that's a wrap-up of the data. I will mention that with regards to the things like fecal coliform bacteria and Enterococcus, remember one of the last things we have to do is the microbial source tracking. We start that when we end our field sampling. So I'm eager to do that. I'd like to do that in November, but we can discuss that further. Of course, the longer we do our field sampling, the more delayed the microbial source tracking will be. We have 2 years of data, so I'm eager to move on and do that microbial source tracking as soon as possible. And then we'll have some additional harmful algal bloom counts to do. We did not see any major rust tide this year, so we've done some of those counts and so far haven't seen that. But though it's qualitative at this point, we'll have quantitative information on that as well. But I think that wraps it up. I'm happy to answer questions and a follow-up, and I'm also happy to take questions by email or also present in person in the near future. Okay, I hope you're all well, and I look forward to talking to you soon. Thank you.